We're going to look at how to conduct or interpret a factorial ANOVA with a non-significant interaction. There's a tutorial on my website related to how to do the analysis in SPSS. This PowerPoint or lecture is going to focus on how we interpret what we do in SPSS. Recall that when we're evaluating a factorial ANOVA with a non-significant interaction, we first need to analyze the model assumptions, determine the interaction effect, and then for a non-significant interaction, we're going to report the main effects. We're going to look at effect size for each independent variable, and then we'll perform any post hoc tests, as well as effect size measures for the significant results. So, if you'd like to look at these just kind of listed, what we're going to do for a non-significant interaction: analyze model assumptions, determine the interaction effect, report the main effects for each IV, look at the effect size for each IV, and then if there's any significant main effects, we have to do post hoc analyses if there's 3 or more levels of an independent variable. So in this particular example, we're going to look at the change in grade point average between males and females based on note-taking method. And so we have 2 different types of note-taking methods and a control group, and a variable for males and females, and then we're going to look at the change in grade point average. And notice on my Shapiro-Wilks statistics, we have 30 males and 30 females, and that translates to 20 in note-take method 1, 20 in method 2, note-taking method, and 20 in the control group. And notice that all of my results for the normality assumption are met, that all the values are greater than 0.01, and so we've met the normality assumption. We can go on. Also notice that my homogeneity of variance assumption is met. P is greater than 0.01, and so my variances are homogeneous. We've met the model assumptions for ANOVA. So then the next thing we do is we look at the interaction effect. Notice here that the interaction effect is not significant. P is greater than 0.05 here, which means we can interpret the main effects. There's no statistically significant interaction. As a matter of fact, if you were to graph this, you would see that there is no statistically significant interaction. The pattern of responses for males is the same as the pattern of responses for females. Note that note-taking method 2 for females is the highest, as it is the highest for note-taking method 2 for males. And notice that the control group scored the lowest for both males and females. So we can see here that what's going on for males is the same thing that's going on for females across note-taking methods. We can generalize the results. There's no statistically significant interaction. We saw it statistically, and now we see the same thing graphically. So we can look at each of the main effects, and notice that both of the main effects are statistically significant. And here we see our effect size, that for sex, we've accounted for 22.7% of the variance in the model, a large effect size. And for note-taking method, almost 40% of the variance is accounted for, also a very large effect size. If we want to look at the effect size for each independent variable, you can see that the mean differences between males and females are located on this table. You can see that the mean for males is 0.38 and the mean for females is 0.19, and you can plug those mean values into your Cohen's d formula to find out the effect size of the Cohen's d. Now notice that for note-taking methods, you can see the means from note-taking method 1, note-taking method 2, and the control group. You can also see the grand mean here at the bottom. Because you had a statistically significant difference in note-taking methods, we might need to look at mean differences in note-taking methods And so you have 3 levels here, and so we can compare method 1 to method 2 in the control group, method 2 to the control group. So you can see your mean differences here, and you can also look at your post hoc analyses and see what value, what was statistically significant. We know that there was a difference between method 1 and method 2. We know that there was a difference also between method 2 and the control group. So between method 1 and the control group, there was not a difference, but between method 2 and the control group, there was. So that's also kind of interesting, and we could use these mean differences here to compute our Cohen's D's as well.